Okay, so welcome back. We are doing our this problem for integrated to 5.5 numbers 1 and 2. And so when we're doing problems like this, they're kind of expecting you to remember stuff from way back when, and it's okay if you don't remember how to do everything. Okay. So the first question says you use what you know about triangles to write a paragraph proof that proves the sum of the angles of a quadrilateral is 360 degrees, and then support your justification with a diagram. So I am not going to write the proof for you, but I am going to draw a picture for you just so you can see what it's going to be. Mainly because your test tomorrow has some proofs on it, so I want to make sure that you're comfortable with it. Now, don't get bogged down by the statements and all that other stuff. Just know that you can get a pretty good understanding of this. So the very first thing I'm going to do is I'm going to draw a quadrilateral, and it doesn't have to be a rectangle. So I'm specifically not drawing a rectangle. Maybe it looks like this, and then maybe it looks like this. Okay, so let that catch up to me, and then I will write this proof with you. So I'm going to pretend that this is, oh, it's not catching up. Hold on a second. There it goes. So when we're doing proofs like this, generically, I'm just going to say given there's two triangles. Okay, so let me insert a table. Go this way like that maybe. Okay, so this is your statements, and then this is going to be your reasons. So I'm going to say given that we have triangles ABD and BCD. Okay, so I'm just going to say given. So we have to start somewhere, and then they said about triangles to write a proof. So I'm going to start with the fact that these are triangles. So what do you know about triangles? Let's see, what do you guys know about triangles? Let's see. And specifically, we're trying to get to 360 degrees here, right? And then I will give you a hint by numbering my angles. Yeah, very good. So one of the things that you'll remember is that in a triangle, the sum of the measures of the angles equals to 180. So I'm going to write that out. I'm going to say measure of angle 1. It's not supposed to be capital, but I'm just going to kind of push on. Plus measure of angle 2 plus measure of angle 3 equals to 180. Now I'm going to put that for the other one too. So measure of angle 4 plus measure of angle 5 plus measure of angle 6 equals to 180. Oops, not 10. So the reason why we can write that is because, let's see, I can write that because of there's that theorem that we said. I don't even think we named it, but it was like one of the first ones. Let's see, triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. So you could either write this as your reason, or you can call it by the triangle angle sum theorem. So I'm going to call it by its name, or actually I'm going to just write it. So in a triangle, the sum of the measures of the angles is 180. So you don't have to write it like this, right? Sorry, I just want this to be on this side and then this to be over here. That's pretty good. Okay, so you don't have to write this all out, but you have to just give me the idea on why you can write that. Okay, so the next thing that I want to do is, again, I'm trying to get to the sum of the angles of the quadrilaterals. So do you see A, B, C, D? They add up to 360. So that's where I'm going. So down here, it's going to say the sum of the measures of the angle of a quadrilateral is 360, right? We proved it, right? So Do you see where we can go next? What's the next logical statement that we can then use? Yes, very good. So we can add these two equations together. We're going to add these two equations together, and then you'll see what we get. So on the right-hand side, you definitely see 360. Does that make sense? On the left-hand side, we're literally adding all these angles together, and then we'll see what we can do next. So measure of angle, and I want to not make it capital, measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 plus measure of angle 5 plus measure of angle 6 equals to 360. So we're almost there because we have one side of the equation. It says 360. Yay! Right? We just need to prove the other side. And so here, what did you do? Well, we just added the equations together. And is that a legitimate step? Yeah, absolutely. We used it when we were doing elimination. Does that make sense? So we just added the equations together, and that is legal. You can do that. The last thing is I want to name all the angles that are in the quadrilateral. So I want you to pretend that I erase this line here. And so do you see angle 1? Yeah. And so that's angle 1. I see angle 5, but then I have an issue with these two angles and these two angles. So what I'm going to do is I'm going to say this angle here, angle ABC, is equal to angle 2 plus angle 6. Does that make sense? So this bigger angle here is equal to these two. And this bigger angle here is equal to this two. I'm just going to be honest with you. Technically, you're already done here. If you put this in the proof for your test, I would give you like 90% of the points. This last point that I'm trying to get you to see is that I would say all the angles add up to 180. So I just need, 360. So I just need to make sure that you see that measure of angle 2 plus measure of angle 6 equals measure of angle ABC. That makes sense? So I'm going to write that out. So the measure of angle, let's see, ABC is equal to the measure of angle 2 plus the measure of angle 6. And then similarly, the measure of angle ABC is equal to the measure of angle 3 plus the measure of angle 4. And the reason why we want to do that, that's a C. It should have said 2. So the reason why we want to do that is that now I can talk about these angles as one big angle instead of two littler angles. So then that way it makes sense. So this is called the angle addition postulate. Okay. The angle addition postulate just means, and I'll write it here, it means angle, not there, here. Angle, I shouldn't use a minus sign because that makes it look like that. Angle plus angle equals bigger angle. Does that make sense? Okay, and then the last thing that I would do is I would substitute this back in, and then it all shows it equal to 360, and then you're done. So this is going to look like this. So 2 and 6 are going to be gone. So I can actually copy this, and I'll show you what I do here, and I'll highlight so that you see what became what. So I'm going to get rid of 2 and 6, measure of angle 2 and measure of angle 6. And in its place, I'm going to put measure of angle ABC. And instead of 3 and 4, I'm going to put measure of angle ADC. Okay, and I'll show you why. Because 2 and 6 2, and 6 were equal to ABC. That's why I put ABC. So I just did a lot of like substitution. And same thing goes with 3 and 4. Instead of 3 and 4, I just put ADC. So that's what we call substitution, and then we're done. Substitution. All right. So this is a pretty solid proof. And then when you move over to number 2, now you can write the equation and say all of these things add up to 180. So I'm not actually going to solve this one for you. I'm just going to set it up. So now we know, because of our past work, we can write 4x plus 23 plus 16x plus 15 plus 6x minus 5 plus 7x minus 3 equals to 360 degrees. And then you can write that, you can solve that equation for that and find out whatever x should be, right? Make sure you pay attention to, because a classic question and a classic mistake students will make is they find x, they're so excited, and then they think they're done. Make sure they're not asking for an angle measurement and they're just asking for x, like this one is. All right.